Hello viewers, I'm Kausalya. Today we are going to find admittance parameters of a two-port network. So this is the given problem. Determine the admittance parameters of the two-port network shown. So here this is the two-port network. It has two ports, one dash input port and two dash are the output port. So here we are going to find the admittance parameters. So first let us write down the respective voltages here. So V1 is the input port voltage and V2 is the output port voltage. And what about the basic expression here? Admittance is given like this. I1 is equal to Y11 V1 plus Y12 V2. And I2 is equal to Y21 V1 plus Y22 V2. So here what are all the admittance parameters? Y11, Y12 and Y21 and Y22. So now the same thing. In order to find this Y11 and Y21, we are going to make V2 as 0. When V2 can be made 0, when that is V2 is nothing but the output port voltage. So when we can make this V2 0, once it is short circuited, right? If you short circuit these two terminals, then obviously the value of V2 will be 0. So here this is what we are doing. First we are making the value of V2 as 0. So in order to make V2 0, here this output port is short circuited. Now I1 is the current which flows from this, which flows through the input port, and I2 is the current from this side. Now we are going to calculate the value of V1. So what is mean by V1? V1 is nothing but I1 into Z. Okay, the basic formula is V is given by I into Z or I into R. So here we have all the parameters, right? Here we have an inductor and a capacitor. So here it should be written as V is equal to I into Z. So here what is the value of Z? When you look at this circuit, you see here this port is short circuited. What does this mean? The current I1 which flows from this side, it goes like this, it goes through this path and it returns back. It won't flow through this line. What is the reason? Because the current will always select the least resistance path or zero resistance path or negligible resistance path. So here when you compare these two lines, this is the line which has minimum resistance. So the current will flow through this 2 ohm resistor and it will flow like this and again it returns back. So here this inductor and capacitor are rejected. So what is the value of impedance now? These two things won't come into picture. So now what is the value of impedance? So here we are having only one resistor whose value is 2. Therefore V1 is given by I1 into 2. So when you rearrange, I1 by V1 is nothing but 1 by 2, which is 0.5 mho or Siemens. So this is the value of Y11. It is very easy, right? Now we are going to find the value of Y21. So here you see, when you look carefully, as I already said here, this terminal, that is this branch is eliminated or rejected. Now you see I1 and I2 are opposite in direction, right? So here I2 is nothing but minus I1. Therefore here again the value of V1 can be written as V1 is nothing but, what is the first expression we had written? V1 is nothing but I into 2. What is I now? I is nothing but, you see I2 is equal to minus I1. Therefore here I1 can be written as minus of I2, right? Here it is I1. So I1 is nothing but minus I2 into 2. Again when you rearrange here, we are getting the answer as I2 by V1 is given by minus 1 by 2. So here the answer is minus 0.5 mho. Therefore the value of Y21 is minus 0.5 mho here. Am I making clear? Because here we are having only 3 elements and this branch is eliminated. So when you remove this branch, you see the circuit is the same, right? The circuit is very simple. Therefore the value of this I1 and I2 remains the same because these two things deals only with this 2 ohm resistor. Right. So here the value of Y11 and Y21 are the same. Now here we are making our V1 as 0 to find the remaining two parameters. So how to make V1 0? We have to short circuit the input side. So here it is short circuited, therefore the value of V1 is 0 here. First we start with finding the value of V2. So V2 is nothing but I2 into Z. So here in this case you see this is your I2, and when this I2 reaches this node it gets divided into 2. Right. So here these two terms, that is these two branches are connected parallelly. Therefore what is the value of impedance? So when you combine these two things, these two elements are connected in series and that combination is in parallel with this 2 ohm. Therefore here 2 ohm is parallel with 2s plus 1 by 2s. So here how to calculate the effective impedance? This is your Z1, this is your Z2. So what is the formula? Z1 into Z2 divided by Z1 plus Z2. So here just substitute the values. Okay, after substituting, the next step is for the numerator part here, not only for the numerator, for both the numerator and denominator, we have to take LCM. So once you take LCM, you see here we are getting 4s square plus 1 by 2s and here 4s plus 4s square plus 1 by 2s. So both these 2s terms will cancel and here the value of Z is given by 8s square plus 2 divided by 4s square plus 4s plus 1. Here I have multiplied this 2 inside the elements. Right. 2 into 4, 8s square and 2 into 1 makes 2. So this is the value of your impedance. Now you can substitute this value of impedance in this formula. So value of V2 is given by I2 into this term. So again when you rearrange, we need only I2 by V2. So when you rearrange here, this is our value of Y22. So since this has S parameters, no need to mention any unit here. Okay, you just write it as Y22, it's enough. Now finally we are going to find the loss parameter. So for that, here we are going to use the current division formula. You see, Y12 is given by I1 by V2. We had already calculated the value of V2. So here we are going to find I1 now. So here from this diagram we are going to calculate the value of I1. So what is the total current here? The total current is I2. And what is the resistance which is opposite to this current? The resistance which is opposite to the I1 is 2s plus 1 by 2s. Right. So when you apply the current division rule, I1 is nothing but total current multiplied by opposite resistance. Here the opposite resistance is 2s plus 1 by 2s divided by total resistance. You have to sum all the three. Right. So here I1 is equal to minus I2 because the direction is opposite, into opposite resistance is 2s plus 1 by 2s as just now I explained, divided by total resistance. So here you see we need I1. So here the total current is I2. The direction is opposite. Right. Therefore here we are writing I1 is equal to minus I2 multiplied by what is the opposite resistance? To this I1 the opposite resistance is 2s plus 1 by 2s. So this is what I had written here. 2s plus 1 by 2s divided by total resistance. Here the total resistance is you have to add all these three. So 2 plus 2s plus 1 by 2s. So here you see this is your total current multiplied by opposite resistance divided by total resistance. Okay, this is a current division rule. So once it is done, the next step is to take the LCM. So after taking LCM, you see here both these denominator terms, they cancel each other. And finally here the value of I1 is given as minus I2 into 4s square plus 1 divided by 4s plus 4s square plus 1. So here now we are going to substitute the values. We know I1 and V2 we had already calculated. So once you substitute, you see here I2 terms cancel each other and both the denominator terms they get cancelled. So the remaining parameters are minus of 4s square plus 1 divided by 8s square plus 2. So in the denominator part you see we can take 2 outside because both these terms are divided by 2. So when you take 2 outside, what happens? Here 8 becomes 4s square plus 1. So here these two terms get cancelled and finally here we are getting the answer minus 1 by 2 which is minus 0.5 mho. So here in this case, we have all the 3 parameters as numerical values. Right, we have numbers as answers but one parameter have S term. So don't get panic, this is correct. Because here we have S parameters, right? We have a capacitor and an inductor. So it is obvious to get the answer in terms of S. So that's all. If you have any doubt, let me know in the comment section. Thank you.